Okay, now you all can see my...
Yeah, we can see your presentation. All yours.
Oh,
thank you, Jose.
Sorry. Okay. The title of my presentation is Machine Vision, why right now is the moment to face all challenges. And I will explain that. Okay. Let's start. Okay, a brief presentation of my company, of Center and me. What does Tecnalia in machine vision? We have about 31 years designing, developing, installing, and maintaining applications. More than 250 projects developed and installed in different areas. And we are working mainly in applied research and development, within the limit of the state of the art, but also we have 20 patents in this area. So we are keeping that research, but applied. That could be the view. And who is this man? Who is me? About 29 years of experience in this sector, and about 6 years teaching these technologies at Deusto Engineering University. Okay, let's start with the task. This is a brief introduction about what is artificial vision or machine vision in Industry 4.0 framework. I could say that it's automatic or assisted process of information acquired represented by means of assimilable to our human visual perception. It's a definition. There are two main aspects: acquisition by visual means, hardware tools, image acquisition, photonic aspects, we will see. And after that, processing software to obtain some result information. The idea is we will have data acquisition by means of we use light in a wide definition of light, all the spectrum, in order to obtain information. And with this, we using different physical aspects like optics or similar, like electronics and other things, we get information to the memory, to some kind of processing memory, in order to have an image or similar. With this, we obtain features and other kind of things, measurements and so on. And we can do classification and defect detection. But with all this, maybe in some cases we can apply intelligence in order to solve one application. But have in mind that in all these stages we have a lot of data. If we apply intelligence to all this data, maybe we can use this data to obtain relevant information to take that information where, when, and how it is needed. That is my view of this 4.0 view. Okay, it's related to obtain more information that we can only can solve an application. We can obtain a lot more information. That could be a view. Okay. As an introduction, lights and shadow of conventional machine vision. We are working in machine vision for a lot of years. There have been several cases of success in machine vision, multiple facilities operating for years. But also there are areas of failure, more or less related to changing conditions, the adaptability, wide typology of parts and defects or range of analysis, the learning capabilities, some difficulties, and in all those cases, cost-benefit balance. I will put you a small video of one case, a real case of a web. Okay, I think, are you watching the video?
We can see the video, Jose. We don't hear anything, but we can see it.
Yeah, that's it. This is a Hewlett-Packard webcam. Theoretically, the webcam can follow the user and can focus on the face, okay? But this man is explaining that it's not following him because in the designing of this application, they don't have in mind the different colors of the skin, okay? But when his colleague is white and it's working fine, okay. But nothing happens. Okay. It's only a sample. Okay. But we all have in mind that in recent times, we can see a lot of applications that defy some of the classic limitations. In this other video, we can see a machine-based conventional machine camera for automotive industry, for assisting driving. It's a camera in the front of the car, capable of, in all conditions of light and different typical condition of driving, capable of assisting the system. And a lot of typical systems used for this kind of application are capable of doing that in different applications with a lot of different cars, with a lot of different changing scenarios. And they are working. And why is this? What happened in this period? Later, we will see that revolution, okay, and related to this. Let me go on. The classical elements in machine vision, the point of view of software, we have that photonics, obtaining information. We have the image in memory, and typically the engineers with developing this kind of applications started with some kind of pre-processing, threshold morphology and other kind of things, selection of characteristics based on the experience and test that those engineers did. They selected the kind of characteristics that we'll use in segmentation, classification, both of them, and after that, analysis and result of the. Okay. But what was the problem here? When we obtain images like this, we have different layers of information, of this kind of information, matrix of numbers. That's the real thing. If we have a camera here, we obtain this kind of matrix, but if we change a little bit vision or light or other things, the information changes dramatically. There must be a kind of going up of the information. We must not treat numbers. That's the real thing. And we are doing these kind of things for a lot of time, but with more or less success. Let's go on. Now, present and future scheme, because this technology is everywhere, and you have heard about that for sure. We probably keep on doing some pre-processing, but after that, all the processing, a lot of processing, is nowadays made by this kind of deep learning structure, because the deep learning, the system learns in a way similar to humans, not the same thing, because we can't explain nowadays the way our brains work, but it's in the way of reinforcing the characteristics or the processing that make the learning optimum. That could be the way. There's no engineer here, only defining the architecture. But after that, the system learns by itself. That could be. And all these stages are new, okay? This new view of deep learning. Let's go on. Okay, and why now and not in the 80s? We used to use neural networks in the 80s. There are three main aspects that have changed these years. First of all, GPUs is a way of processing, parallel processing in low cost and with a very high computational capabilities. There have been companies related to video games and graphics that has developed this kind of GPUs. They are cheap and they are very powerful. And are working very fine. The other big aspects of this new revolution is the algorithmia. There's a lot of new algorithms that are capable of processing this kind of architectures, and there's a lot of work in this area.
Jose, sorry for interrupting. You have a couple more minutes.
Oh, okay. I go fast.
No problem.
Okay, and a lot of tagged images. We have a lot of images in Google and other servers with describing images of different samples. With all of that, we have done this kind of deep learning architecture with a lot of advantages, much higher performance, and linked the engineer from feature selection, learn indefinitely, and much more stable. Here you have a sample of the learning context of the classification made by universities. Here we start to use deep learning. And here, this is the ratio of the humans, 5.1. And you see in 15, the automatic system is better than humans, okay? Okay, I will go fast. But there's still a lot of work to do. We must reduce the work involved in learning. You probably know that labeling is a hard work. We must make models self-explanatory, not black boxes. We can have confidence in an expert, but if the expert is not human, we need more, and not black boxes. And we need metrics for the user, not for scientists. We need to measure how good is the system in real conditions, and in some way predict performance before starting to work in it. And with all this in mind, there's a lot of related applications. I have here, depending on the time, I will explain. There are some applications that we are using different architectures of deep learning. We are working with people that is expert in this kind of new architectures. In this case, single shot detector deep learning, capable of detecting in hot condition surface defects to locate and to classify defects in real time, 10 meters a second. Okay, this is the case. This is another kind of, with this view of photonics, using hyperspectral or spectral images. So using machine learning and deep learning technologies for classification of diseases in plants and other things. And this view is machine vision as a service. Okay? We use deep learning also for infrared and other kind of applications. Hyperspectral, like I have said, for recovery of materials, separation and other things. We use the rest of a spectrum like Raman of FTIR spectroscopy, TIR's radiation and X-ray for detecting things inside bodies. And this new view is the using of deep learning, not only from machine vision aspects, for other kind of sensors. It's the fusion of the technology in a way similar of our brain uses our sensing, our nose and this is a kind of architecture that we are developing. It's very interesting. Probably could give very more reliable results. Okay, that only one kind of sensing or physical aspect. Okay, with all those in mind, with some conclusions. Machine vision is a well-established technology. There's a present revolution, new artificial vision tools that can overcome, in some cases, humans, but not is all done. There's a lot of things to do still. Research. Photonics is the key information source and the whole spectrum that can enlarge our capability of watching and seeing. And this interdisciplinary vision, co-creation with clients, as the K of best solutions, collaboration with SECPHO agents that enable a good design and service, and the flexibility of the design and the solution that could make the application make it better. And as an end, I will use the quote of Arthur Schopenhauer, philosopher, every man takes the limits of his own field of vision for the limits of the world. And that's not true. Okay, that's my presentation. Thank you very much.
Thanks, Jose, for your talk. Very inspiring. I see here one question so we are a bit short of time, so I would just say this question that I have here. Then if you can leave your email maybe on the chat, so everyone can contact you. So Alex Suarez Duarte asked you that regarding the camera problem that you presented, where the software fails to focus on the dark skin guy, do you believe that this was a limited data set use problem, or it's a social cultural problem?
For sure. The idea is a kind of the design of that kind of application probably was only tested with a small quantity of people, not having in mind all the application. That is a problem. Even with this technology, that could be a problem, this kind of distortion of the data set. But we must have all that in mind. With previous architectures, that problem was huge. And nowadays, if you have enough data, you can be more flexible. I will put my email there. And
okay, put it there, because I'm sure that some people will have questions for you. Thank you very much for your talk again.
Thank you, and take care.
Thank you, you too. So now I'm trying to. So it's time to move to our next speaker, who is going to be Victor Blanco.